Set notation. Think of a set as simply a collection of unique items. We give a set a name with a capital letter, like A, B, or S. The items inside the set, which we call elements, are listed inside a pair of curly braces. For example, S equals 1, 2, 3 is a set named S containing the numbers 1, 2, and 3. A set can contain anything, like mathematical constants or even a description, like E equals X, where X is an even integer. Next, we have membership. This is how we say if something is in a set. The symbol that looks like a stretched E means is an element of. So 2E, 1, 2, 3 simply reads 2 is an element of the set containing 1, 2, and 3. If an item is not in the set, we just put a slash through the symbol, which means is not an element of. Now, let's talk about the relationship between two sets. This symbol means subset. A set A is a subset of set B if every single element in A is also found in B. Think of it like this. 1, 2 is a subset of 1, 2, 3 because both 1 and 2 are in the larger set. It's like one box fitting completely inside another. Okay, let's look at what happens when we combine sets. This U symbol stands for union. The union of two sets is a new set that contains all the elements from both sets. The key word here is or. An element is in the union if it's in the first set, or the second set, or both. So if A is 1, 2, 3, and B is 3, 4, 5, their union is 1, 2, 3, 4, 5. Notice that the number 3 is in both sets, but we only list it once in the final result. The opposite of combining everything is finding what's in common. This upside-down U symbol stands for intersection. The intersection of two sets gives you only the elements that appear in both sets. The key word here is and. Using the same sets, the intersection of A and B is just 3, because 3 is the only element that exists in both A and B. Finally, what if two sets have nothing in common? This is called an empty intersection. For example, if set C is 1, 2, and set D is 3, 4, they have no overlapping elements. Their intersection is the empty set, which we write as empty curly braces or with the symbol empty. It's a set with nothing in it.
Inequalities are the symbols we use to compare two numbers. First, we have the less than symbol. If we write A less than B, it simply means A is a smaller number than B. Think of it on a number line. A would be to the left of B. The opposite is the greater than symbol. A greater than B means A is the larger number and is to the right of B on the number line. Now let's add a little line underneath. The symbol less than or equal to gives us two possibilities. The first number is either smaller than the second, or it's the exact same number. And similarly, greater than or equal to means the first number is either larger or it's exactly equal to the second. So inequalities tell us the relationship between two specific numbers. But what if we want to talk about an entire range of numbers? That's where intervals come in. An interval is a continuous stretch of numbers on the number line, like all the numbers between 1 and 5. The most important thing to learn here is the notation, parentheses and square brackets. They tell us whether the endpoints are included. Think of it this way. A parenthesis is like an open gate. It means we get infinitely close to the endpoint, but don't actually include it. A square bracket is like a closed gate. It means we absolutely include the endpoint in our set. Let's look at the different types. First is an open interval, written with two parentheses. This means we're talking about all the numbers strictly between A and B, but not including A or B themselves. On a graph, we show this with open circles. Next is a closed interval with two square brackets. This includes everything. A, B, and all the numbers in between. We show this with solid, filled-in circles. We can mix them. A half-open interval, like bracket A, comma B, parenthesis, uses a square bracket for A and a parenthesis for B. This means we include A, but we exclude B. Sometimes these ranges don't have an end. We call these unbounded intervals. For this, we use the infinity symbol. A key rule to remember is that infinity is not a number you can reach, it's a concept. Because of this, infinity always gets an open parenthesis. So, parenthesis A, comma infinity means all numbers greater than A, while bracket A, comma infinity means all numbers greater than or equal to A. The same logic applies when we go towards negative infinity. Let's tie it all together with a quick example. Imagine we have the inequality -1 is less than or equal to x, which is less than 3. First, look at the -1 is less than or equal to x part. The or equal to sign tells us we need to include -1, so we use a bracket. Now look at the x is less than 3 part. The strict less than sign means we exclude 3, so we use a parenthesis. Put them together, and the inequality -1 less than or equal to x less than 3 becomes the interval -1, 3 parentheses. And that's it. Inequalities compare numbers, and intervals use a simple bracket and parenthesis code to describe entire ranges of numbers. That's how we handle a single range. But what happens when we have two different ranges of numbers to consider? That's where we use two special operations, union and intersection. Let's look at a clear example. Suppose we have two intervals. Interval t is -2, 4. All numbers from -2 to 4 inclusive. Interval f is 1, 6. All numbers between 1 and 6 excluding the endpoints. For finding the union, ask yourself what numbers are in A or B. We take the lowest point from either interval, -2, and the highest point from either interval, 6. Since -2 is included in A, we use a bracket. Since 6 is excluded in B, we use a parenthesis. This results in bracket -2, 6 parentheses. Now for the intersection, ask yourself what numbers are in both A and B. The overlap starts just after 1 and ends at 4. Since 1 is excluded from B, it can't be in the overlap, so we use a parenthesis. Since 4 is included in A and is also in B, we use a bracket. It results in parenthesis 1, 4 bracket. So, union combines everything, and intersection finds only the common ground. These are powerful tools for working with more complex problems.